Oh, hi, I'm Steve Weavers, creator of the Imaging Whiteboard. In this video, I'm going to go through the building, training and deployment of a convolutional neural network using the Imaging Whiteboard. We'll need to start with some training data, and fortunately on the internet there is some data. This is a collection of handwritten digits from 0 to 9. And you can go and get these. They're free to anybody. And I've already managed to get these and download them. And here we can see kind of what they look like. We'll notice they're white on black. The original images you get are black on white. The original images are white on black. These images are black on white, and I've made that conversion already using the Imaging Whiteboard, but I'm not going to go through that here. Okay, so we can see we've got all the digits there, and lots of them. There's training data, and there's also test data as well, and we're going to use them for their purposes. Now, to build the neural network, first of all, from the Tools menu, we open the CNN configurator. Okay, and we get a window like this. What we need to do is to begin by creating the architecture for the neural network. And we can do that by adding convolutional pooling and fully connected layers. But the architecture I'm going to use is an architecture that was already used for this purpose, and it's the LE-net. We can read about this on Wikipedia. There's a Wikipedia page about it, and if you scroll down, there's a very nice diagram here which will show the actual architecture of the network that I'm going to build. Now the images are 28 by 28. We know that. So the first thing I'm going to do is add the first convolutional layer. Okay. The width is 28 and the height is 28 because that's the size of the images. I'm going to put in one channel because they're grayscale images. If they were color images, I'd put in 3 for the number of channels. The kernel size we get from here is 5 by 5, so let's put a 5 in the kernel size. And the number of filters that's used is 6. Okay, so we'll put 6 in there. And we'll notice that the input count and the output count has already been set based on the numbers we've just entered here, so you don't need to put those in. The activation function we can see from the diagram here is sigmoid, so we're going to select the sigmoid for that, and that's the first layer, so we add that. Next we add this pooling layer. You might notice I've used the same color convention, so let's open this one. Now this pooling layer, okay, yeah, it's 2 by 2, so let's put 2 there. They usually are. The stride is 2. And the number of filters is also 6. So the image input is 24 by 24 by 6 here, and that indicates that there's an error. Okay, so if I'm going to finish doing this, so first of all we'll set up the average, because that's it is an average pooling layer. Okay, and we click OK there, and it's going to open that up and see it. Now, I said I'd made an error. That was in the convolutional layer, so I'm going to go back in and edit the convolutional layer. And what I didn't do is I didn't tick the padding box. You should notice this convolutional layer is meant to have padding here. So if I click the padding box, okay, and go OK, we should see that the width in the pooling layer is increased to 28 by 28 with an output of 14 by 14. So that's correct. Okay, so I'm now going to go and add the next convolutional layer. This one has no padding, still has a 5 by 5 kernel size, and the number of filters here is 16. Okay, which we can see from here. Okay, and the activation function again here is sigmoid. Okay, and we have no padding, so I'm just going to click OK there. Okay, we should be able to see that's come up. And the fact that there's no padding has reduced the width from 14 to 10 on the way through. That's the original convolution layer with the padding is 28, and you get 28 out, and that's what you get for adding padding, because it'll do the edges. Okay. Next we add the next pooling layer. Okay, this again is an average. Okay. Kernel size is 2, stride is 2, number of filters again 16, and everything else is filled in for you. So we just click OK there. Okay, and now we just have the fully connected layers. So we click the first one, and we can see that there's 120. So the output is 120 here. Let's just put that in. Okay, the input count is derived from the previous pooling layer. The activation function there is a sigmoid again. Do that, so we click OK. The next one, we have an output count of 84. And again, a sigmoid activation function. And we click OK. And the final one has an output count of 10. And there's no activation function on this, so we're just going to click OK there, and we can see that the output count is 10, and this is the output layer that we can see here. So that's fully complete now. So what we can do now is we can save this and bring it back, and I'm going to just restore that from one I built earlier, which is actually the same, but in this one, there we are. Okay, right. So we've restored that. It's actually the same network, but in this one I've actually put the categories in. Okay, and that's just going to save us a little bit of time. Now what we can do is start the training. I could just go and pick the source directory here and just leave the file name blank and just click train and go and do it. That's a bit tedious because we want to keep doing this repetitively. So there's a sequencer, and I can go and add steps to this to create that, but as usual there's one I prepared earlier, so let's go and restore that. Okay. Sequence. Okay, and here you can see we've got 3 steps. We've got a training step, and we train from the training data. We've got a test step, and we test from the test data, and then we save it, and then we save it to a directory there. So after each test or each cycle, we'll actually go and save the video. So we can kick this off now just by simply clicking the repeat button. Missed a step. Let's go set up the gradient descent. I'm going to pick mini batch 32. I'm going to make the learning rate 0.1. Okay, so now I'm just going to kick off the training. Okay, and it's telling me quite correctly that the model must be initialized, so I'm going to initialize it. Okay, and try that again. Okay, so now we're running through the first training cycle, and we can see we're counting the batches and the files. And what happens here is we randomize the images, and let's just click the show button. We can see that. Okay, so all of the images in the training directory have been put in random order and selected into batches of 32 because we've mini batch 32. So we'll run through a batch of 32 and then we'll perform the back propagation for that batch, go on to the next batch, and so on until we've completed all the files. Okay, and this takes a little while, so I'm going to pause this here and let it catch up. Okay, the first training cycle is almost complete, so we'll just let that play out. Okay, so now the sequencer has moved on to the test step, and we've just started the the first test cycle. So I'll pause it again and get back when that finishes. Okay, the first test run finished. We started the second training run. We can see the accuracy is pretty rubbish at this point. It just thinks everything's category 0 and gets 100% there and 0 for everything else. So what I'm going to do now is I'm going to pause it again, and I'm going to go back to the same model that I've trained earlier. Okay, so I've now loaded a fully trained model and I've run the test again, and we can see we're getting a much better result here of about 93.62%, which is not great, but it's okay. Now, if we go and take a look here at the results graph, we can see a history of what was going on here. So the accuracy started off here about 10% and didn't do much for the first few iterations, and then suddenly found its footing and very quickly went up to around about 90%. Made some slow progress. But by the time we've got to around about, I don't know, 75 iterations, it's pretty much flattened off. That's the accuracy graph. We can also see the cost graph, which is perhaps a more accurate way of thinking about it, but in reverse, and it goes through much the same kind of process in reverse. So you can see we've got a much better model here. So the question now is, well, what can we do with it? So I'm going to pause this and bring up a whiteboard that we can use this in. Okay, so I've loaded this fairly simple test whiteboard here. We can see we've got the multi-image input here, and I've loaded it with the test images that we use to test the neural network. And into the image classifier, I've loaded the model that we've trained. Okay, so now if I just go clicking through this, we can see that the images, the test image is coming up here. The category here is coming up, so it's well, that's incorrect. But this is 4. So we can kind of see that we're getting decent results there through this. Still not useful. I'm going to pause this and bring up a more complete application, and we can take a look at that. Okay, so this is a much more complete application. What I've done here is just written down the first 8 digits of pi on a piece of paper, and just took a picture of it. And that's what I'm going to use for the test image. So we come through here, we set a threshold just to get it black and white. We crop the image size, so we just got the bit we're interested in. So let's just see how that works. So we just cropped it to that. Okay, and we've done a little bit of morphology on it. We've eroded the dark just to remove the vertical lines, because this was lined paper that I wrote it on, and some of the smaller digits here have been removed. We set memory so that we can actually see what we're doing. on the output finally. And then we do an image invert because we're looking for white blobs in a black background. We've used the blob counter control to highlight all the individual images, and you can see they're outlined in red. And I'm just going to run through all the blobs here. We're going to do some more morphology because the pen I use seemed to be a little bit thicker than the training images, so that'll come down. And then finally we scale it to size because we must have a 28 by 28 image because that's what the model's been trained on. So now let's see how we do. So I'm just going to click this. Okay, we run through it. So we got 3, 1. Well, that should be a 4. So we got 1, 5, 7 should be 9, 2 and 7. So we've got 6 right out of 8. So we've got about a 75% accuracy there, which is actually not pretty bad. Not bad at all, because what we're dealing with here are digits that are not, strictly from the training set. And I think we can begin to see some of the reasons here that perhaps neural nets in the past have not really lived up to the promise that they had. There's a great deal of difficulty in actually getting a neural net deployed and properly, getting decent results out of it. A lot of it's to do with getting training images which represent, the final task. Spending enough time training, and then perhaps dealing with the black art of, how do I architect the neural net? What's the training regime I should use, and so on. But I think what you've seen here should briefly give you the idea that you can try out a lot of things with this, and make your own assessment. Build a net, train it, and deploy it, and perform all the surrounding processing that you would need to do.